Costa Rica, a paradise known for its lush rainforests and pristine beaches, is facing a fiery challenge. Volcanoes, long a part of the country's landscape, are showing signs of increased activity. In recent weeks, Poás and Turrialba, two of the most closely watched volcanoes, have been spewing ash and gas into the atmosphere. These eruptions, while not yet catastrophic, have raised concerns about the potential for larger, more destructive events in the near future. Scientists are closely monitoring the situation, analyzing data, and looking for clues to understand what lies ahead for this volcanically active region. The recent eruptions serve as a stark reminder that Costa Rica sits atop the Pacific Ring of Fire, a zone of intense seismic and volcanic activity. The Ring of Fire, stretching for approximately 40,000 kilometers, or 25,000 miles in a horseshoe shape, is home to about 75% of the world's volcanoes and 90% of its earthquakes. It is a place where the Earth's tectonic plates collide and grind against each other, creating immense pressure and heat that can trigger volcanic eruptions and earthquakes. Costa Rica's volcanic landscape is a testament to the dynamic forces shaping our planet. Before a volcano erupts, it often provides a symphony of warning signs, subtle cues that hint at the growing unrest beneath the surface. Scientists use a variety of instruments to detect these warning signs, which can include increased seismic activity. As magma rises within a volcano, it can fracture rocks, creating earthquakes that can be detected by seismometers. An increase in the frequency or intensity of these earthquakes can signal an impending eruption. Ground deformation is another key indicator. The pressure of rising magma can cause the ground surface to bulge or deform. Scientists use GPS stations and other instruments to measure these subtle changes in the Earth's shape. Additionally, gas emissions are closely monitored. Volcanoes release gases such as sulfur dioxide and carbon dioxide from their vents and fumaroles. An increase in the volume or composition of these gases can indicate that magma is nearing the surface. In the case of Poás and Turrialba, scientists have observed a steady increase in seismic activity in recent months, along with elevated levels of sulfur dioxide emissions. These observations, combined with other indicators, suggest that the volcanoes are in a state of heightened unrest, and that further eruptions are possible. Thermal imaging is also used to detect changes in temperature, which can indicate rising magma. Drones provide a unique vantage point, allowing scientists to monitor hard-to-reach areas and gather crucial data. Volcanic eruptions, while awe-inspiring displays of nature's power, can have a devastating impact on communities and ecosystems. Ashfall from eruptions can blanket the landscape, damaging crops, contaminating water supplies, and causing respiratory problems in humans and animals. The recent eruptions of Poás and Turrialba have already impacted communities in Costa Rica, forcing the closure of Poás National Park and prompting concerns about air quality in surrounding areas. The economic impact of volcanic eruptions can be significant, particularly for countries like Costa Rica that rely heavily on tourism and agriculture. Ashfall can disrupt air travel, forcing the cancellation of flights and deterring tourists. It can also damage crops, leading to reduced yields and economic losses for farmers. The long-term effects of volcanic eruptions can be felt for years as communities struggle to recover and rebuild. However, ongoing monitoring and preparedness efforts can help mitigate these impacts and protect lives and livelihoods. A history of fire and fury. Poás and Turrialba's past eruptions. Poás and Turrialba, two of Costa Rica's most active volcanoes, have a long history of eruptions, some gentle and effusive, others violent and explosive. Poás, known for its acidic crater lake, last erupted significantly in 2017, sending ash and gases into the atmosphere. Turrialba, which had been dormant for over a century, roared back to life in the 1990s with a series of eruptions. It continued its activity with major eruptions in 2016 and 2021, blanketing nearby areas in ash. These past eruptions serve as a reminder of the inherent volatility of these volcanoes and the potential for future eruptions, keeping scientists and communities on alert. The Ring of Fire. Geological forces at play. The Pacific Ring of Fire, a zone of intense seismic and volcanic activity, owes its existence to the relentless movement of the Earth's tectonic plates. These plates, massive slabs of rock that make up the Earth's lithosphere, are in constant motion, driven by the heat emanating from the Earth's core. Along the Ring of Fire, the denser oceanic plates are subducting, or sliding beneath, the less dense continental plates. This process of subduction generates immense heat and pressure, melting rock and creating magma that can rise to the surface, fueling volcanic eruptions. The resulting volcanic activity can produce explosive eruptions, ash clouds, and lava flows, dramatically reshaping the landscape. As we dive deeper into the world of volcanic activity, it's crucial to understand how scientists monitor these powerful natural phenomena. In this chapter we explore the various techniques used to keep a vigilant eye on volcanoes. Seismographs play a pivotal role, detecting the slightest tremors that may indicate magma movement beneath the surface. Gas emissions analysis provides another vital clue, as changes in the amounts and types of gases released can signal an impending eruption. Satellite imagery offers a bird's-eye view, capturing thermal anomalies and ground deformation that might be invisible to the naked eye. These advanced methods collectively enable scientists to predict potential eruptions, thereby helping communities prepare and mitigate risks. These tools and techniques are not just scientific marvels, they are lifelines for those living in the shadow of these majestic, yet potentially destructive giants. Understanding these connections between volcanic activity and geological phenomena is key to safeguarding lives and property. As we journey through the annals of volcanic history, we encounter some of the most significant eruptions that have left indelible marks on our planet. Mount Vesuvius, 79 AD, a catastrophic eruption that buried the Roman cities of Pompeii and Herculaneum under a thick carpet of volcanic ash and pumice, preserving them for centuries and providing us with a snapshot of ancient Roman life. Krakatoa, 1883, an explosive eruption that obliterated over two-thirds of the island and generated massive tsunamis claiming over 36,000 lives. The explosion was so powerful that it was heard 3,000 miles away and caused global climate anomalies. Mount St. Helens, 1980. In the United States, this eruption dramatically reshaped the landscape, blowing off the top of the mountain and resulting in the largest landslide in recorded history. The eruption killed 57 people and caused over $1 billion in damage. These historical events not only remind us of the raw power of volcanic activity, but also underscore the importance of understanding and monitoring these natural phenomena to protect communities and mitigate future risks. In this chapter, we discuss the future of volcanic activity in Costa Rica and around the world. With the relentless forces of nature at play, predicting volcanic eruptions remains a complex challenge. However, advancements in technology and increased scientific understanding offer hope. Modern monitoring techniques including satellite imagery and seismic sensors provide invaluable data. This information helps scientists predict imminent eruptions with greater accuracy, giving communities precious time to prepare and evacuate if necessary. Education and public awareness are also key components of preparedness. Governments and organizations are working tirelessly to inform citizens about evacuation plans and safety measures. In Costa Rica, regular drills and community engagement initiatives ensure that people know how to respond when a volcano threatens. The importance of preparedness cannot be overstated. While we cannot control volcanic activity, we can mitigate its impact. With concerted efforts and continued advancements, we can protect lives and build resilient communities that stand strong in the face of nature's fury. As we look to the future, let us remain vigilant, informed, and prepared, ensuring that we are ready for whatever challenges lie ahead. A changing climate, a restless Earth, exploring the connection. As the Earth's climate changes, scientists are investigating the potential links between climate change and volcanic activity. While the relationship between these two complex systems is still not fully understood, some studies suggest that climate change could influence the frequency and intensity of volcanic eruptions. For example, the melting of glaciers and ice caps could reduce the pressure on underlying volcanoes, potentially triggering eruptions. Additionally, changes in rainfall patterns could alter the stability of volcanic slopes, increasing the risk of landslides and other hazards.